This is question number 4 from the 3.3 notes on product rule and quotient rule. And this is a function that is a product of a monomial 5x and a binomial cube. So I'm going to use product rule here to find my derivative. So I went ahead and wrote my first function and found the derivative of that. So if my first function is 5x, I just use the power rule, and the derivative of that is 5. And then my second function is a binomial cube. So I use the power rule with the chain rule. So my base was not a plane x. It's a quadratic binomial there. So I had to tack on the derivative of that base. So the derivative of the base was 2x, and I simplified it down here. So I'm just going to apply my template for the quotient rule to find my derivative. So I wrote my f of x notation with the prime in it. So f prime of x, I'm finding the derivative. And I just plugged in my first times the derivative of the second plus the second times the derivative of the first. So that's my raw derivative. If we weren't asked to do anything else but find f prime, I could type this raw derivative in my math lab and it would count it right. But we're being asked to simplify your answer by factoring out a GCF if possible. So I need to do some algebra to simplify this derivative. So I'm going to go ahead and multiply my factors in the first term, and then I'll see if I can simplify the factors in the second term, and then we'll factor out a GCF if possible. So let's go ahead and multiply these first two factors. So order doesn't matter when we multiply, so I'm going to multiply 5 times 6 is 30. Then x times x is x squared, and then I have my binomial squared in that first group, plus there's really nothing I can do in this second group but just reorder the multiplication. So I'm going to put the monomial 5 first, and then I'll write the binomial cube there at the back. And now I'm going to look at those two groups again, but I'm going to ask myself, is there a GCF in between those two groups? And the answer is yes. So 30 is a multiple of 5. And I have 5, which is a multiple of 5, so my GCF has a 5 in it. And I also see that I have the binomial occurring in each of those groups. So in the first group, the binomial occurs twice. There's 2 factors of the binomial. And in the second group, the binomial occurs 3 times. So the most number of factors, binomial factors, I can take out are 2 of them. So I'm going to take out a binomial square. So that's my GCF. So let's go ahead and factor that GCF out and see what remains. So I'm going to write my GCF out here. I can factor out a 5, and I can factor out 2 of the binomial factors, and I'll see what's left in each of the groups when I do that. So if I start with a 30 and I factor out a 5, that'll leave me a 6. That x squared didn't factor out, so it stays there. And I had 2 binomial factors, and I factored them both out, so there's no binomial factors left in that term. Okay, and then in the second group, I factored out the 5, and I have 3 binomial factors, and 2 of them factored out. So that's going to leave me 1 binomial factor remaining. So there's an understood exponent of 1 there, but I'm not going to write it. And since I'm adding this binomial, I don't really need those parentheses, because when you distribute addition, it doesn't really change the signs or anything. So that's going to be important to recognize. We don't need those parentheses because the next step is going to be to combine like terms in those brackets there. So if I don't need those parentheses, then I can see I have 6x squared and I'm adding 1 more. So when I go to clean all this up, when I factor out the GCF, 5 binomial squared, then left over would be 7x squared minus 4. So this is the simplified derivative after factoring out a GCF.